India produces over 150 million metric tons of rice every single year. It is the foundation of the daily diet for 1 billion people across the country. But researchers at the Florida Museum of Natural History have identified a strict biological limit that this crop is rapidly approaching. For 9,000 years, human civilization and rice have grown together. Now, escalating global temperatures are tearing that relationship apart. Why are scientists warning that by the year 2070, modern farming technology might not be enough to keep rice on Indian plates? The answer lies inside the plant itself. It is breaking down at a cellular level, creating a very real threat to national food stability. To understand the vulnerability, we have to look at where domesticated rice actually comes from, the Yangtze Valley in China. As early farmers slowly expanded their reach, they selectively bred the crop to survive in colder climates, migrating it south into the Indian subcontinent. But while humans successfully taught rice how to survive the cold, the plant never developed a biological defense mechanism against extreme heat. The Florida study analyzed 803 distinct archaeological sites to map exactly where humans have successfully grown rice throughout history. This chart maps out thousands of years of crop yields against local climates. Look at the data distribution here. Across human history, we have never successfully cultivated rice in regions where the average annual temperature exceeds 28 degrees Celsius, or 82 degrees Fahrenheit. Agriculture didn't conquer nature. We simply found an invisible thermal allowance and stayed inside it. Now, the climate is pushing us outside those boundaries. That historical boundary is becoming a modern crisis. In many agricultural hubs across India, summer temperatures routinely break 40 degrees Celsius. At that temperature, plants experience heat stress. It is the botanical equivalent of a human suffering a sudden heat stroke. Once the thermometer hits 40 degrees, the plant's internal biology completely halts. Photosynthesis shuts down, and the crucial grain-filling process fails. You get a stalk full of empty, useless husks. Right now, farmers are fighting back by pumping massive amounts of groundwater into their fields, using heavy irrigation as a physical cooling system. But soaking the soil only buys a few hours. If the air above the water remains at 40 degrees, the internal machinery of the plant still fails. Over the next 50 years, climate projections show northern and central India facing sustained, continuous periods above that critical 40-degree survival threshold. When the crops fail, the immediate impact falls on millions of small-scale farmers who rely on these harvests for both their sustenance and their income. One proposed solution is to move farming away from the plains entirely, pushing rice cultivation up into cooler, higher-altitude mountain regions. The math simply does not support this. Mountain terraces require intensive labor and offer a fraction of the arable land. They cannot replace the sheer square mileage of the Central Plains. A localized biological failure quickly cascades into a national shortage, driving massive economic displacement as people are forced to leave their land. Our only viable workaround to this biological limit is inside the lab. We have to rely on advanced genetic engineering and new breeding techniques to force an adaptation the plant couldn't make on its own. Developing these heat-resistant strains requires billions in research funding. Getting those expensive seeds into the hands of the world's poorest farmers will require immense political coordination. If we don't engineer a biological solution in time, the staple crop that fed the last 9,000 years of human history won't survive the next 50.